Hi everybody, thank you for checking out this video. I'm pretty excited about doing this. I'm sure you're really excited. I just want to show you a couple of things real quick as you're watching this. I will be flipping back and forth from my paper and pencil like this, and then I'll be clicking to what number we're on. So let's say we're on question number 1. You'll be able to see that pop up on your screen like this. So if you don't want to see question 1 or 2 or 3, you should be able to kind of just drag through and get to the problem that you want to see. So we are going to start with question number 1, and that's what's up there. So we're going to move over here and let's check it out. Question 1 says there are 15 crayons in a bag. So that's kind of a big thing. Some of you guys are big into highlighting. We're definitely going to keep that in mind because that's the total number of crayons. 4 blue, 2 red, 1 green, 5 yellow, and 3 orange. What is the probability of selecting a blue and then a red with replacement? So we're going to do that first. And when I see the word probability, you guys should automatically think of the word fraction. And that fraction is what you want over the total. So I'm going to write that down. Hopefully you guys can see that. It's a little sloppy there. Sorry about that. Okay, so what do we want? The very first thing it's saying is we want a blue and then a red with replacement. So what we want is blue, and I look and I see 4 blue, and then the total number of crayons in there, the total number is 15. With replacement means I'm gonna take that crayon out, I'm gonna look at it, and then I'm gonna put it back in the pile. So I still have 15 total crayons. But when I go to draw the second time, I still have 15. But what do I want this time? Well, the second time I want a red, and if I look up there, there's 2 red. When we do that, we multiply first draw times second draw, 4 times 2, multiply the tops. I get 8. 15 times 15 is 225. That will not simplify, so that's my final answer. Okay, the second one, though, says without replacement. So I have to look and I have to say, okay, we're going to do the same problem but without replacement. So the first time, the probability of getting a blue, there's 4 that I want out of the 15 total. But the second time, without replacement, I want red, but there's 2. But how many total crayons are left? Well, you got to pretend that I drew a blue, because you always draw what you want or get what you want. So I got 1 blue, just 1, and I'm holding that in my hand, so that means there's 14 total left because I lost a blue. When I multiply that out, I get 8 over 210, and that will simplify to 4 over 105. That's my final answer. Sometimes you'll see these as a decimal, and all you would do is just take 4 divided by 105 in your calculator, and that would give you the answer for that. So we are now on to question number 2. Okay, so I'm going to switch back to that. Okay, question 2, let me zoom out a little bit here. Okay, it says you spin a 5-section spinner, numbered 1 through 5, roll a 6-sided die and toss a coin. How many total outcomes are possible? So in this problem, I see the word outcomes. And in outcomes, that's a hint that we're not going to we're not going to have a fraction, but we are going to multiply. But we're going to multiply totals. And when I look in there, the spinner, so I'm going to write, we've got a spinner. We have a die, and we have a coin. So I asked myself, okay, zoom in a little bit there for you. On my spinner, how many outcomes are there? Well, there's 5. I can spin a 1, 2, 3, 4, 5. So there's 5 different things that can happen with my spinner. On a die, they're telling you it's a 6-sided die. Sometimes they'll say a fair-sided die. So 6-sided die, I can get a 1, 2, 3, 5, 1, 2, 3, 4, 5, or 6. So there's 6 of those. And then a coin, there's heads or tails. 2. It's going to multiply those. 5 times 6 times 2 is 60. So there's 60 total outcomes. Okay, so that was a pretty quick one. We're going to go to question number 3 here. So if you're fast forwarding, welcome to number 3. Whoops. So let's go back. Okay. All right, so question 4. This one's a big one because two-way tables, I think we're really good at those. I'm just going to zoom in so you guys can see the table. But the question is really important, and I will go over that part. So it says, what is the probability? So we know right there we're going to have a fraction of what we want over the total. Of randomly selecting someone who likes skateboards. So I know I need skateboards. That's going to be what we want. Okay. Given. That's the big word right there, given. They do not like snowmobiles. So that's what that says there. Given that they do not like snowmobiles. So when you see the word given, that's telling you we're only going to use a part of our graph. Either going down or to the left and to the right. Well, in this problem, they say, given they do not like snowmobiles. Sorry about that. So what that's telling me is we're only going to look at this part right here. We're only looking at they do not like snowmobiles. So when I look in that, there is a total, because probability is what you want over the total. My total, I see, is 55. The question asks, though, what's the probability of someone who likes skateboards? So as I look in this section right here, and I see like skateboards, it's right there, 45. So there's 45 that we want out of the 55 total. That will simplify. If you need help with that, let me know tomorrow. That simplifies to 9 over 11. Okay? So when you see given, you got to do just a part. If you see, like on this problem, it might say given that students do not like skateboards. Well, that means I'm going to work in this area right here. And 35 is going to be my total. That's if they were asked, say, given they do not like skateboards. Okay? Alrighty. On to question 4. Okay, question 4 says, let me move here. Oh, sorry about that. It says you roll a standard die, then roll again. What is the probability of rolling an even number and then a 4? So we may not have talked a whole lot about this, but you might see this on a test. I'm going to write the probability of an even. So if you see the P and then a little parentheses in it, that's saying probability of an even. And then we want the probability of a 4. Okay. Well, the probability of an even number is, let's think about it on a die. There's 6 numbers on a die, but there's only 3 that are even. So there's 3 that we want out of the 6 total. Probability that it's a 4, if I look over here, there's only 1 that I like, or want, out of the 6. So we're going to multiply those. 3 times 1 is 3. 6 times 6 is 36. I can simplify that, and that gives me 1 over 12. Again, if you don't remember how to simplify, just ask me, and I'll show you tomorrow. Okay, we're on to the big one, question number 5. I'm going to just zoom in here so you can see just a table that I'm going to make. And you can read the question on your own. So we are going to question number 5. And here we go. Question 5. I'll read it. There are 150 students attending a game. 82 students are sophomores and 68 are juniors. Have no idea where the seniors are. Guess they didn't want to show up. 97 students drove themselves to the game. 60 sophomores drove to the game. What is the probability you select a student that is a sophomore or drove to the game? Okay, so the first thing we need to do is we've got a lot of things going on. We've got juniors and seniors. We've got people who drove, people who did not drive. That's letting you know we got to make a two-way table. So instead of sophomores, I'm just going to write 10th, 11th. That's my juniors. Got a T for total. Got the students that drove. Oh, students that did not. We'll just put did not. Did not drove. Did not drive. So let me zoom in out a little bit. So it's there we go. It looks better. Okay, and then my total. So as I'm doing this, we're going to fill out what we know. Well, they say 82 students. Let's go ahead and make our table. There we go. Okay, it says that 82 students are sophomores. 68 are juniors. It says there's 150 total students. You got that? 97 students drove themselves. So when I look at drove, I'm going to go over here and put 97. I don't know if the grammar's right on that, but oh well. Okay. And then 60 sophomores drove the game. So here's sophomores, here's drove. There's 60 of them. And that's all they really give you. But we can fill out the rest. What we got to do is we got to add this number and this number to get 82. So 60 plus something's 82. Or we could just subtract 82 and 60. Gives me 22. Can also add going this way to get my total. So 60 plus something's 97. Or you can just do 97 minus 60, whatever's left, which will be 37. Here I've got to add going down. So 97 plus something's 150. Or I can just subtract 150 from 97. And that gives me 53. And then here, I'm just going to subtract those two. So that's 31. Okay. Now this is a tricky one because this question says this or that. So here's what we're going to do. We're going to look at two things. It says, what is the probability that you select a sophomore? Okay. So sophomores are right here, and there's 82 total sophomores. But then it says, or drove to the game. I'm going to use a different, I'm going to go this way. Or that they drove to the game. And that's kind of hard to see, so I'll kind of shade it in. Okay. If you look, I've circled the number 60 twice. I've circled it here and I've circled it here, which means that I can't add these two together, 82 and 97, because I want 10th graders. Well, there's 82 total, and I want who drove. Well, there's 97 total. But this 60 is used in both, which means I would count those 60 kids in this total and 60 in that total. And you can't double count people. So the way I look at it is the very first thing is what's the probability that is a sophomore? Well, I know that there's 82 total sophomores. There's 82 10th graders. And then how many total students drove? Were 97, but I can't count those 60 because I've already counted them here. So the only thing I can count is the 37 juniors that drove. So this is 11th that drove. It's 37. So if I add those together, I get 119. Out of the total number of students that went to the game, it's 150. That one's really tricky. That's one of the hardest ones. Make sure you look at that one because that one will probably definitely show up again on your test. So let's go to number 6. Okay, we're on to question number 6. Okay, here we go. So they just want to know what angles are congruent to number 4 in this problem. So I'm going to zoom in a little bit there. Okay, so when we talked about these, okay, we always said angles across from each other are vertical, and they're always congruent. So if here's angle 4, the one across from it is 7. So I can say 4 is congruent to 7. And then if I pick this line up and move it over here, 4 would go in the same spot as 2, and 7 would go in the same spot as 5. So what you want for your answer is you want to say angle 2 is congruent to angle 5, which is congruent to angle 4, which is congruent to angle 7. Okay, so there you go. That's your answer for question number 6. We're on to number 7. So let me get my page flipped here. To number 7. Okay. All right. And then what they're asking for in 7 is which angles are alternate interior? Okay, big concept we covered this year. Interior means inside. So at one time we talked about like a hamburger and a patty. This is the patty part because it's in between. So that takes care of my interior. Those are the interior. All of those 2, 6, 3, 7. I just said the answer. But those are all on the inside. And alternate means that I'm on this line and I alternate. So this is same side interior. These are supplementary, but these are alternate because one's on one side, one's on the other side. If I went this is on one side and that's on the other side, that's supplementary. So that cannot be alternate interior. I got to say 2 and 6. So angle 2 and angle 6. Notice they're not congruent. The only way they'd be congruent is if they're 90 degrees. So you just say 2 and 6. And then my other ones, 7 and 3. Those are the same. So you can flip the order on that, but that's okay. But that's your answer to number 7. All right, number 8. So we're now on question number 8. That's another big concept we covered earlier. So here we go. Okay. So question 8 wants to know, we got to solve for x. So if you remember doing these, the way we did it was we looked at, there you go. Sorry it's a little blurry. Sometimes that helps. That did not help. There we go. Okay. So the way we did it was we're going to pick this line up, we're going to put it underneath, and we're going to see where does this sit over here. And that will help us determine. So if I look, this is in the top right corner right here. And the top right corner of this one is right here. That's its corresponding part. So I'm just going to move this down here. And when I look, these are side by side. And side by side are supplementary. Side by side are supplementary. So if it was right here, we would set it equal to each other. Or if it moved on top of this one, we'd set it equal. But since it's side by side, it's supplementary. So we're just going to add those together. 3x plus 21. That's my first angle plus my second angle. 6x plus 15 We're going to equal that to 180. So we're going to collect like terms. 3x and 6x is 9x. 21 and 15 is 36. Subtract 36 on both sides. I get 144. Divide by 9. And I get 16. On this one, it just says solve for x, so we're good. We don't have to plug it back in or anything like that. Okay, on to number 9. So number 9 is going to look like this. Zoom out a little bit. Okay, so they want to know what lines are parallel, but the easiest thing to do, I've talked about this a lot this year, fill out the picture. Just completely fill out the picture before you do anything else. So we're going to go through, if that's 110, that's 110. And then remember, these are side by side are supplementary. So that's 70. These are diagonal. So they're the same, they're vertical. Okay. This one's 60, so this one's 60. This one's 115, so that's 115. That one's 120, that's 120. Okay. Then we can do side by sides. Side by side are supplementary, so it has to be 120. Also, you can always check. You can add those together. They make a circle. That's 360. This one is 65. Side by side, supplementary, so it's 60. So if you look, the numbers that match are right here. So if I look, these two lines share line B, which I'll highlight right here. So that's my transversal. So the lines that are parallel are D and E. They share that transversal, but these are the two lines coming out. So D and E, which is letter or option 4. There you go. All right, we are ready for number 10. So we're on to question 10. Let me get it flipped over here. Okay, question 10. Question 10 wants to know, it's got some options down here. I had to handwrite in my wonderful handwriting up there. Okay, it wants to know which conjecture or guess is correct if I know all these lines are parallel. So this is really just a process of elimination. I'm going to work through all the wrong ones first so you can see, and that'll leave us with the correct answer. So 1, 2, letter A is 1, 2, and 3 are congruent. Well, if I look at 1 and 2 right away, they are not congruent. They're side by side. Side by side are supplementary. The only way those would be congruent is if they were 90-degree angles. They're not 90 degrees because they're not marked. So I know this one's out. Let's go down to letter C. It says 2 and 4 are supplementary. Well, if I take 2 and I move it down, it would sit right on top of 4. When they sit right on top of each other, they are congruent. They're not side by side. They're congruent. So that one's out. 1 and 5, if I take 1 and I move it down here and then down here, it sits on 5. So that's corresponding, or they're congruent. So that leaves me only with the option of 1, 3, and 5 are congruent. Well, if I look at 1, 3, and 5, they all sit in the same spot, the top left, which means they're congruent. Okay, we're on to question number 11. Okay, question 11. Alrighty. It says which reason justifies the statement below. If you look, big thing they're showing you, the only thing that's changing is our signs. When the signs change, that's definition of congruence. Okay. Alrighty. So now we're on to question 12. Question 12 says, which reason justifies the statement? So when I look at this, I'll zoom in a little bit. There's a key here. I see JK here, and I see JK here. I see NP here, and NP here. And then I see plus LM and plus LM here. Well, when I go from this, I see blue, yellow, red, yellow. But when I go over here, all I see is the blue and the red. The yellow have disappeared. They're gone. They've been covered up. See how those are the same now? Well, the way we got rid of it was if we were adding LM, we would be subtracting LM to both sides. If I subtract LM to both sides, that gets me there. So this is the subtraction property of equality. Whoa, that's coming right at you. Sorry about that. Okay, so subtraction property of equality. Let's go on to question 13. Here we go. 13 is a proof. One of our favorites, I think. And here we go. Trying to get this whole thing in there for you. Okay. So the easiest way I think to do is go through, find your givens. So I'm going to highlight those for you. Here's a given, and it stops at that semicolon, I think. Yeah, semicolon. So that goes right there, and that's given. They've already given me that. But then I have the other given, which is right here, and that is step number 3. That is right there. So that one's given. Well, to do this proof the fast way, we know that when we see the word bisects, we know the next one's going to be definition of a bisector. But I'll just show you real quick. It says KM, this line right here, bisects this angle. And when it says that in step 1, step 2 says then I get these 2 equal angles right here. That's what that part says right there. Well, when that happens, that's the definition of a bisector. I've got a big angle. It's been cut in half by that line. That is the definition of a bisector. Three was given. 4, if I see bisect, that means this one's going to be definition of a bisector. I can show you that again real quick. I've got this angle right here. It's been cut in half by this line, which creates these 2 equal angles, which is right here. So I know that that is the definition of a bisector. And then the last one. This one could be tricky. Some of you guys may think substitution. Some of you may think that is transitive. Let's check it out. Colors are good to use. Here I have JKM, and I'm going to make that purple. I'm looking for JKM again. Oh, right there it is. So I've got that. MKN, I'm going to make a red oval. There's MKN. MKN, there's MKN. Okay. And then NKL, NKL. So if I look at it, if blue is equal to red and red's equal to yellow, if these are both equal to red, then I know that these two are equal to each other. So like if I cover up the reds, what's left between these two steps? Well, blue and yellow. So that's what I get left. They are both equal to that red circle, so they were equal to each other. So that one is transitive. One thing before you move on to this problem, this next one, just want to show you. When we look at these, you got to look at the ones with the congruent signs. You can't, if it's got words in there, you kind of skip those. You want to compare all the things with equal signs or congruent signs. So just keep that in mind. Okay, we are going on to question number 14. So question 14. Actually, I think I probably might just stop on 14 and we do 15 in class. So question 14. We'll see. Okay, so question 14. We got to look at these. I'm just going to kind of quickly go through these. Let me see if I can zoom in a little bit there for you. Okay, so the first one says QR is equal to QR. You're looking in the mirror. Everything's the same, so that's a reflexive property. That should be letter F. Question 2, it says I see AB here. I see AB here. I see CD here. I see CD here. But each one of them, to go from the one step to the next, if this, then that, they both have this part added additionally, and they're actually adding. So that's the addition property of equality, which is letter A. All right, question 3. If you look at it, so if I look, here's RS, there's RS, here's XY, there's XY, there's TU, okay, and here's, I'm going to just make this different. So the only thing that changes from the if to the then, if I look, that's the same, that's the same. All I did was change one thing. And right here it's saying wherever TU is, I can make it WV. So that TU I changed to WV. I only swapped out one thing. By knowing that, we should definitely know that that's substitution. That's E. Okay. Option 4, we have an equal and a congruent sign. That change, all that was definition of congruence. Here I've got I got AB, I got AB, I got CE, I got CE, I got BC here, I got BC here. So if purple is equal to yellow and red's equal to yellow, if they're both equal to yellow, I can cover that up and they're equal to each other. So remember, I cover that up and now they're equal to each other. That's transitive, which is H. 2xy equals yz. From here to here, the 2 disappeared. From here to here. The only way to get rid of that is divide by 2 on both sides. You want to divide by a 2 on both sides. I get xy equals 1/2 yz. So that's division D. Q is between P and R, then PQ plus QR equals PR. Well, if I just draw a quick picture, I've got point P, I've got point R. I put point Q between it because that's what they tell me. See, it says Q is between P and R. Then PQ plus QR equals PR. So that's little part plus little part equals big part. Segment addition, letter K. And then the last one, I have 2KL equals KL plus MN. So if I subtract KL to this side and subtract KL to this side, all that's left over here is KL, and all that's left over here is MN. So that's subtraction property. Okay. We're going to leave number 15 and 16 for class tomorrow. I think that's long enough for now. Thanks for listening. Make sure you like this video. Make sure you subscribe. And if I can get enough subscribers, I will hopefully get some merch going someday. Thanks for listening. If this is helpful, I'll continue to do these. If not, I won't. See you tomorrow.